Hey, GED students, I had a student, Devin, who was working on the advanced level practice of visualizing word problems from the math crash course. And he got stuck on this problem. So just fair warning, you wouldn't want to tackle the advanced level practice unless you had some math background. This one requires a pre-knowledge of geometry. But let's go ahead and take a look. It says Lynette walked 600 meters directly south, then 500 meters directly east. To the nearest meter, how far is she from where she started? So this is one of those word problems that it'd be really hard to know what to do if you didn't visualize it, if you didn't draw a picture of what was going on. Let me go ahead and give that a try. So first off, Lynette walked 600 meters directly south. So let's imagine here she is, and she walks directly south. We'll do the traditional north up, south down, west off to the left, and east off to the right. So 600 meters directly south, and let's go ahead and label that. So there she is. She'd be standing here at the bottom of this arrow. Then what does she do? She goes 500 meters directly east. Let's get out another little arrow to model that. So starting here at the end of this path, she goes about 500 meters this way, 500 meters directly east. Now it says to the nearest meter, how far is she from where she started? How far is she? We're looking at the distance from where she is based on where she started. Well, where is she right now? She's here. And where did she start? She's here. If you want the distance between those 2 points, we got to connect them. Let me go ahead and see. There, that line I just drew represents the distance between those points. What I'm looking for is the length of this line. Now, something super interesting has occurred. Notice what I've drawn here. I've drawn a triangle. Her path makes a triangle, and not just any kind of triangle, it's a right triangle. Because she went directly south and then directly east, those two, I should say, movements are at a right angle from each other. And so we've drawn a right triangle here. And now we're going beyond the visualizing part, and this is where we have to bring in the geometry. This is where we're supposed to know that if you know two sides of a right triangle and you want to find the third, there's a formula for that. Hit up the GED formula sheet. That formula is known as the Pythagorean theorem. The Pythagorean theorem says, I'm using a new tool today, so I'm a little slow, guys. I have a brand new computer. So we have a squared plus b squared equals c squared. And I just want to reiterate that this is the Pythagorean theorem or the Pythagorean formula, and it is used to find the missing side of a right triangle when you know the other two sides. You have to know the other two sides. Okay, so now it's also super important to understand that A and B are the legs of the triangle. The legs of the triangle, those are the ones that are around the right angle. So I always remember their legs because they form an L. You can see it. So this 600 and this 500 are the A and B. And then the C is always the hypotenuse, the one across from the right angle. So let's go ahead and plug in the information we know. Whenever we use a formula, we start by writing down the formula, but then we put in any information we know. So A and B are these legs, and it doesn't matter which one's which. I'll just go ahead and plug it in. So I'll plug in 600 for A. So I get 600. I won't drop my square. I won't drop my plus. And I also know what B is. That other leg is 500 meters long. So I need to square that. And then that whole jazz will be equal to c squared. Pick up your GED calculator. You don't need to be able to do these by hand. You can totally do them in a calculator, although they're not actually that hard to do by hand. But anytime you have geometry application problems on the GED, you do get that lovely calculator. So if you square 600, you can use the x squared button in your calculator, or you can just do 600 times 600. You'll get, let's see, 36 with 4 zeros after that. So what is that? 360,000. Beautiful. And then if you square 500, let's see, we'll get 25 with 4 zeros after that. So 250,000. And that whole jazz is equal to c squared. Great. Now we are simplifying the left-hand side. We're obeying the operations. So, we squared first, we did exponents before we handled addition. So now I'll go ahead and do my addition. 360,000 plus 250,000 gives me 610,000. And that whole thing is equal to c squared. Now, careful, a lot of students will stop right here. We're not looking for c squared. We are looking to solve for c. C is the hypotenuse, the length of this. So it's super important that you do that final step there to isolate c, to get c by itself, get rid of that square. In order to get rid of things in math, you have to do the opposite. So we're not going to square. We're actually going to do the opposite of squaring. We are going to square root. The opposite of squaring c is square rooting c. Now you can do whatever you want to an equation, as we know. That's solving, but you have to do it to both sides. And let's take a look then at what happens. So the opposite of squaring is square rooting. Those two things cancel, so c is alone, just like we wanted. And then that math, that's something to do in your calculator. So the square root of 610,000. So to type that sucker into your calculator, you're going to need to use that green button up at the top left, the second button. Okay, because the square root key is right above the x squared button. And then you type in 61, you don't need the comma, I should take out the comma, 61,000, and then you press enter. I said 61,000, it's 610,000. And I get 781.02, yada, 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 yada. It goes on and on. A lot of times you will get these not perfect answers when you're dealing with the not perfect real world around us. Don't be scared by them, but do look for rounding directions. There'll often be rounding directions when that happens. And I can see here that there were some rounding directions in this problem to the nearest meter. So if it just says meter without a place, I'm just talking about to the nearest unit, I'm going to end up rounding right here at the decimal place. So consider the next number. It is not big enough to matter. I will just throw the whole thing out without making a difference. That sucker is about 781 meters long, meaning that Miss Lynette is now 781 meters from where she started. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.